Kia ora and welcome to Byted's Commands PLD. So this is for the Dinosaur Commands kits from the Play Code Learn series. My name is Sarah Washbrook and I am Product Development Lead at Byted. I will be helping you to understand how to use the Commands kits in the classroom. Today we're going to be exploring and recapping different aspects from computational thinking, in particular algorithmic thinking. We'll also be exploring how to transition students from using the unplugged kits into the Byted app. And developing understanding of how we use game-based learning in the Dinosaur Commands kits. We'll also have a look at some of the resources that are available to you as teachers through the online teachers portal. During this session, you will notice that there are icons or images that are bright yellow with the play icon, as you can see the animation in the top right-hand corner. In these cases, this means you can stop, pause the video and have a go yourself. If you wish to view these slides later, you can see that there is a link at the bottom, which you can just type in and use. Also, during the session, if you manage to see our Explorer Ed doing his dance moves, as you can see in the animation to the right, you can take on an activity. So when you see Explorer Ed dancing, consider an activity. You could say something, you could do an action, but when you see Explorer Ed, I want you to enact that action. So just to recap from previous PLD, we do have other kits in the series. Our first kit is Dinosaur Steps, which introduces aspects of computational thinking with a focus on algorithmic thinking, sequence, debugging, decomposition. The next kit in the series is Dinosaur Loops, which reiterates what's gone on before, but also develops and deepens understanding of pattern recognition, in particular, iteration, inputs and outputs, efficiency, and then obviously we go into our Dinosaur Commands kit, which is what we're focusing on today, which goes deeper into computational thinking and computer science concepts, including things like introducing variables, functions or procedures, conditional statements, events, broadcasting, and much more. So, like I've mentioned before, we do have two other kits in the series aimed at younger students at primary level. So, Dinosaur Steps is our introductory course, which uses a play-based approach to actually help to teach through an unplugged to digital methodology. And then we have our Dinosaur Loops kits, which grows on or develops on the conceptual ideas and technological literacy and vocabulary that the students have learned using Dinosaur Steps. We're going to be focusing Dinosaur Commands today. So if you have the Dinosaur Commands kit, you will see that it is a little bit different to the previous kits. There are no jigsaw pieces to put together. This is because we use a game-based learning approach to teaching and learning for the slightly older students at primary level. However, the approach is the same. There are still lots of manipulatives, unplugged components that are put together to enable the students to understand the different concepts, leading into using the Byted app. Here's some more examples of how we can actually use the app. Students also have the opportunity to be creative digitally too. They can design and create their own avatars and design and create their own dinosaur characters, so they can customize them. They can also use our AR dice mode, so they can use these for other subject areas. For example, in maths, if you're looking at statistics, they could actually use these to help and support them in that learning too. So in the kit itself, we have our dinosaur land boards, and it is progressive learning that goes on here. Our main board is the Cretaceous period. So you can see this actually fills out the whole board. But on the back of the board, you've also got Triassic period and Jurassic period. Now these, as you can see, have smaller amounts of squares in the grid, but they are larger. And so If you are introducing students to using commands, you may want to choose to use the Triassic or Jurassic periods first before going into the bigger map. Obviously, this is also teaching them about history and teaching them about science too, because we are a fully integrated, STEM integrated kit. So take some time to explore the lands. Oh, and it looks like I'm hiding an Explorer Ed. So if you've noticed Ed is behind me, you should be doing an action. So just a quick recap from the kits before. We focus predominantly on different computational thinking concepts with the use of the kits. So we have algorithms, pattern recognition, logical thinking, abstraction, and decomposition. There are many, many aspects and facets to computational thinking, but these are the key concepts that we cover using the commands kits. So let's focus on algorithmic thinking. Within Dinosaur Steps, like I mentioned before, the key areas to focus on were step-by-step instructions, logical order, what an algorithm is, debugging, and then converting algorithms into programs. This deepened and developed in Dinosaur Loops, but we also introduced inputs and outputs, so technological systems, iteration through repeats and loops, functions and procedures, efficiency, and prediction. In Dinosaur Commands, we're going to be introducing some new concepts, some new ideas and skills and techniques that students will find beneficial when they're programming. So we also introduce variables and random variables, events and event handlers, conditionals, and broadcasting, to name a few. So how do we use the kits themselves? So you can see here we've set up one of the boards, and what you can do is you can use the different cards in the kit. So if you start by placing start and finish flags on, and you can choose a couple of the dinosaurs. Now you can keep them flat if you want to, or put them into their stand so they stand up, and position them anywhere you wish to on the board itself. So this is a starting point. Then what they do is we have broken down the learning journey or the learning process for the students to make it easier for students to understand what they have to do to create an unplugged algorithm, but also to support them if they come across any problems or if they find any errors or bugs in the algorithms that they create. So we've tried to make sure that it's very visual, very hands-on for the students to learn. So as you can see, the first thing you need to do is you need to decide how Explorer Ed is going to get from start to finish visiting the dinosaurs. Before we do that, what we're going to do is you need to decide on which way Explorer Ed is facing. So there is a yellow arrow card, and you place this on the start card. So you can choose which way Ed is facing, and you can obviously this makes the resulting answer more easy or more difficult. Then plot the path with the footprint cards. So what you're trying to do is get the students to consider the fastest route, the most efficient route from start to finish. Once we've done this, we can use the cards, the algorithm cards. You can see we've got different command cards to actually come up with this step-by-step instructions. Now, we start off by making sure that this is very clear, and you'll notice that it is a very long instruction set that we have here. There are no repeats and loops at this stage. So what the students do is you can see that we have different arrows. So blue means move forward, green means move backwards, and then you've got left turn and right turn. And left turn and right turn means that they stay in the square and they rotate a quarter turn. So what we do is you can see that there are some mini start and finish cards, and you can create your sequential instructions or algorithm using the command cards following the footpath that you've created. When you're ready to test the algorithm, the students, as you can see, they can put Explorer Ed in his stand, and they can place him on the start box. What they then do is one student will read out the instructions and the other person follows. If there are any problems or issues, then they work through logically to try and find the problem and to solve it. So when they're testing and trialing, many of you may know, but this is called debugging. So what they'll do is they may find that there is an error in the code that they've created, the algorithm they've created. So it's really important to learn how to spot those errors and to debug them. In the code that we can see here, or in this previous one, I can put this back on the screen, there is actually a bug. All right, so you may wish to pause and see if you can find the bug in the code. So did you find the bug? You will notice that the bug is one of the turning commands. Okay, and what they have to do is then obviously debug the code. So they will actually change that to create the correct answer. In the online portal, there are images of these little bugs that we've got on the screen here. So you can download and print those and use those to help to support debugging too. The other thing that we want to try and encourage students to do is to predict where the bug is before it's running. All right, so prediction is really, really key. Is can they predict what's going to happen in an algorithm if there are going to be potential bugs? And then obviously they can check and find out whether they are correct or not. So at the moment, we've got very, very long step-by-step precise instructions to get Explorer Ed from the start to the finish. However, we want to make this more efficient because if we were using this as lines of code in a program, it's actually taking up a lot of space. Yeah, and we can actually shrink this down to make the code and the algorithm much more efficient. So it takes up less space and therefore less time to run. So if we have a look at the example on the screen, can you see any single commands that are repeated? So hopefully you notice that, for example, the first three commands, we've got 3 move forward arrows, right? So what we can do is we can actually change that and we can use the repeat cards in the kit. So as you can see, you can have it, so it's instead of having 3 forward arrows, it's actually shown or demonstrated as 1 arrow but times 3. This indicates that Explorer Ed will have to move forward 3 times, which is exactly the same, but it actually is taking 1 line of code rather than 3. As you can see, what we've done is we've now shrunk down the size of the original algorithm and changed it into an algorithm which is using repeated commands, because there were quite a few different sections there which had repeated commands. The next part that we look at, so this is looking at repeats. The next part we're going to look at is looking at actual sections that repeat, not commands or individual commands that repeat. So if you have a look at the algorithm now, our new algorithm, are there any sections that repeat? So hopefully you identified that actually the very beginning of the algorithm is actually is a section of code that is repeated. You've got forward times 3, turn left, forward times 3, turn left. And so this now can actually be shrunk down again using the loop cards that we have in the kit. So as you can see, instead of having a very long algorithm, we can now shrink it down a lot more, and we can showcase that the algorithm needs to be repeated, or the loop needs to be repeated twice. And so this is another way of actually writing the same series of instructions. What you will find is a repeated set of commands is known as a function, or it can be known as a procedure. They have 2 slightly different meanings, but we will use either function or procedure just to help with the students. A function or procedure can be saved and can be used in the algorithm or in a computer program again and again. So if you know something is working well, it can be saved and then it can be recalled to be reused in a program. Take some time to actually convert your very long algorithm into a much smaller one using iteration. So once students have got that understanding of sequential instructions, of debugging, and even using decomposition to break down the actual coding itself, what we're going to do is we're going to focus on some of the newer concepts in commands. So we're going to be having a look at variables. So variables essentially are pieces of information that have values that vary or change during the running of the program. Okay, so to give you an example of this, if you consider the school day, things that are the same during the school day is probably the name of the day, the year, the students' names in the class, the school's address. Those things don't change. But what can change are other aspects. So the weather could change, the season can change, the class that you're teaching could change, and could change for if you've got a timetable where you change classes, then the students in front of you may possibly change. What the students are doing in the lesson changes. So you have different variables. So you can see there's actually quite big connections here to science and scientific experiments. And yeah, having consistent variables or constants, and having variables that change. So this is a great little activity for you to use in your classrooms to introduce variables. So get your students to play a game of rock, paper, scissors. Okay. And they have 1 minute to play as many rounds as they can with a partner. All right. Now, what they have to do, though, is they have to record down who wins, yeah, how many times they win in the games, and how many times that they draw. All right. Now, don't tell them how to do this. Get them to think of a way to record the information down, and get them to do a minute round. And then get them to do it again. So get them to go through a few rounds of 1 minute recording the information. And this obviously game-based approach is really appealing and engaging for the students. Afterwards, what you're going to do is you're going to focus on how those students actually recorded the scores. How did they record the information? And you'll find that there's many different ways, but many of them will do something like this potentially. So they are actually recording in probably a tally. It may be laid out slightly differently, but many of them are very similar. And what you're going to do is you're going to identify from this what are the constants, what stayed the same, and what's changed, what's the variables. So it's a good way to introduce the idea and the concept of variables to students. So as you can see, many things will have stayed the same. Yeah, the player names, so who's playing, the time of each round, everyone had a minute, the types of outcome, did they win or did they tie? What changed was mainly the numerical data for winning or having a draw, so the actual tallies that were ticked off. So what you then explain is obviously that these tallies are the variables, and help students to understand that they're the option, they're the number, that's the data, that's the information that changed during the playing of the game. And this is what happens in a program too. We also need to make sure that variables have a specific name so that the computer program knows what you are referring to. So in this case, our variable's name was player 1, player 2, and possibly draw. When using the commands kits, the students will be using random variables. And in this case, when they're playing with the unplugged kit, you can see that they are going to be using the dice for unplugged variables, for randomized variables. This can be done with the physical dice, or it can be used using the AR dice. The example that we've got here is actually from the apps program itself. So this is how we can actually show the name of a variable in a computer program. Now, at the very beginning, I asked you to come up with an action every time you saw Explorer Ed, and there was a reason for this. This this was a way to introduce events and event handlers. Okay, so when Ed popped up, this was an event. And you acted as an event handler. You saw that event and you reacted in a certain way, causing something else to happen. So this is how we can introduce events and event handlers to students. Events and event handlers are used all the time, and particularly in the game itself. So, in the Escape the Predator game that we have event cards, and there's an event round to introduce what events could be. But when you're using the app, there are different actions that can take place. So, for example, when you tap on a button, it causes something to happen. When you scroll around on the color wheel, it causes something to happen. So, really, it connects to inputs and outputs as well in technological systems. The other aspect that we consider and we introduce in commands is conditional statements. If this, then what? Yeah. And so, if and then statements are ways in which we can offer basically true or false answers. And we give something to happen. If something happens, then something else will happen. And this happens quite a lot in computer programming. It's basically giving options for changes during the actual programming itself. We're introducing students to if this, then what, in the actual game itself. And you can see some of the cards that the students will use and learn about when they're actually playing the Escape the Predator game. Another way of exploring this is there are different types of conditional statements. We have if, then, and else if. A good way to remember this is the text at the bottom there that you can see. If it's sunny, then read in the garden. Else, if it's raining, then read inside the class. Else, if it's cloudy, then read in the library. Else, take a nana nap. So those are the different concepts that are introduced through the use of the Unplugged kit, the Unplugged booklet in the kits, and through the online teaching resources, which we'll explore in a minute. First of all, though, we're going to go into the augmented reality and the digital aspects available in the ByteEd app. So once students have got a very good understanding of the key concepts through the hands-on kit, we take them into the digital side of things. First of all, we're going to explore augmented reality. So AR is different to virtual reality. AR is used in society all over the world nowadays, but what it is it combines real life and digital together. As you can see, there are lots of different examples here of how augmented reality is used. AR is a technological system. And so when we're using this and when we're using our apps and when we're using tablets or smartphones with the app and the augmented reality, you can see it goes through an input, process, output system. Essentially, a camera in the tablet or the phone will scan an image, which is the trigger image. So in our case, it's our dinosaur cards. And then what happens is a computer program, in our case, the ByteEd app, processes that image and it converts it then using our program into a 3D animated model, which you can then view superimposed onto real life. And that is the output. Other outputs are included are animation, audio as well, in conjunction with that 3D model being viewed through the screen. Augmented reality is used quite a bit in our app. Not only can the dinosaurs come to life and you can explore these through the glossary, but like I mentioned before, we have our augmented reality dice. So when you scan the dice cards, you can see that, they can roll the dice. They can choose actually how many dice they want to roll. And you can see the equation or the sum is actually on the right-hand side there. This also introduces variables because every time the dice roll, a different number pops up. Yeah, so it introduces that we've got a different variable. As we mentioned before, students can also explore the dinosaurs through the glossary. They can find out information about the dinosaurs, but they can also scan the dinosaurs. They can bring them to life. They can scale them and make them larger. And they can also take photographs of those dinosaurs in real life situations. The next few slides go in how you can log in. You do need to have a login to get into commands to go with your kit. So make sure you have been set up with your own personalized login. The next stage is going into converting an algorithm into a computer program. And so what we can do is we get the students to go into challenge mode, as you can see here. And there is progressive challenges for the students to work through based on algorithmic thinking. In this case, the AR is set up to appear in a different way. It doesn't have a trigger image to actually trigger the augmented reality model to appear. Instead, you need to make sure that you have a space. It could be a table, it could be a floor. And the camera, in this case, actually scans the environment and places and positions the map on top of that environment. So it's a different form of how AR can be placed in position without using a trigger image. When you're happy with where it's positioned and you can rotate and change things around, you can obviously click confirm. If you're not happy, you can just go back and reset it and you can try again. In this case, the challenges are set up that the students need to try and collect the eggs. So once again, they are using the commands and they are exactly the same as the command cards in the kit. If you find that students struggle to answer the program the first time or second time, they may actually want to set up that challenge in the unplugged version so they can go back to the kit and help and explore that way. Arrow tiles are clicked and dragged to the right, as you can see, but instead of having them separately, you can now put them into repeats. So you can add repeats and you can also add loops into the computer program to enable them to complete the challenge. As the program runs, the play button matches the play button and the testing card in the actual physical kits. And you can see they can follow the progression of that program and the progression of Ed or whoever's moving in the actual app itself. This enables them to actually practice writing programs. Obviously, they can complete challenges more than once if they want to try and make their answers more efficient. Dinosaur Commands, as we mentioned before, connects to game-based learning, and these are just some ways in which it does. Number one, you could actually get them going into developing and creating through the digital app itself and the customize button. You can see here they can design and create their own dinosaur characters and avatars. There is a section in there where you can explore storytelling with AI if you wish to. This is a prototype at the moment. So you can explore the students introducing text prompts and how to create stories should you wish. The other game-based learning is through the Escape the Predator game, and this reinforces all of the content that they've learned by using the kit and the app. These games are both unplugged and digital. To help and support you as a teacher, there are comprehensive teaching resources online through the portal. So if you go to the ByteEd website, you will find that you can log in. And as you can see, there are many, there's a login page there, and you can log in through. There, you will find the courses have come up on the dashboard, and you will see that there are many different resources to help and support you with teaching and learning in the classroom. Basically, you download, use, and go. If you want any further information from ByteEd, then please keep in touch with us. We do have a support email if you would like any more information in regards to Dinosaur Commands, professional learning opportunities, or even the other kits in the Play Code Learn series. But you can also keep up to date with us. We are on all social media. And we do have our own ByteEd YouTube channel, which has more helpful hint videos and support to help you on your way with the use of the Dinosaur Commands kits in the classroom. Thank you for listening to the PLD today. I hope it was supportive, and please stay in touch. Let us know how you get on. Ka kite.